Hello, good morning all. So today I see one very interesting problem on Leetcode platform. It's a complexity of hard type, but if you know the right data structure and right data approach, what you have to use here, so it will be very interesting problem here. So let's go through the problem statement first. So we have to count good triplets in an array. So we are having two array num1 and num2, and both array are having the permutation of 0 to 1, 0 to n minus 1 elements in that array, but the order is will be different in both array. Now we have to find a subset from both array which is same, means xyz. We have to find three element xyz which is in the which is same in the both array num1 and num2 and are in the increasing order, means x should be less than y should be less than z in both array. Okay okay Now let's look into the one example also, where the input is 2013 is the elements of array 1, and for element 2 array 2 the elements is 0 1 2 and 3. Okay, they below they also provide some possible subsets also, like 201 203 213 like that, and 013, but out of all of those triplets, only one subset is satisfying the condition 013, that position should also in the increasing order, that position x should less than position y should less than position z in both of array. It should follow. Okay, so here we can just divide the approach, like we can suppose for middle element y we can just how can we iterate first. We have to iterate of the array, and for middle element we have to find number of elements in the left which is less than middle element, and number of elements to the right which is greater than to the middle element, means y, and take the product of that. So means the total number of good triplet, and doing for each element we have to just iterate over the array and count the possible good triplets here. So but now here we have to count number of elements which is smaller than middle element in the left, and number of elements in the right which is greater than. So for that we can use Fenwick tree. Here is the approach of Fenwick tree will here. Just first try to illustrate how we can map both array in based on the index, means how can we map array 1 with respect to index with the second array. And so just took the example how we are doing. Okay, let's uh, took the this num array num1. So what it could be, num1 is the array which is having elements 2013 201 and 3 like this. And for num2, what will be the array, this num2, the array will be 0 1 2 and 3. So now first our first approach is to first we have to map both array together. So we are taking one more array position to suppose to, where we can in this array we can map the array 2 with their index like this. So for 0, the element is having on 0th index, one element is on first index, second element is on second index, and third element is on third index. Okay, we updated this position to post to array. Now we map the array 2 with the array 1 with their course with their index. So we took one more array like mapped, we called it mapped. So here we can just map array 1. So for this array 1, like 2 is in 2 in this position, array, what it could be, 2. So we can update it as simply 2, like this. 2 here means we will update like this. Mapped array will be what, pose position of 2 with nums 1 at I, like this. What will the value at num of I, like this. So for current element is 2. 2 for 2, what will be the value is 2. For 0, what will be the value is 0. We are just mapping the same. Okay, so our final map array will be this 2013, which is just mapping. So here we reduce the problem in the increasing order. So all elements are in increasing order now. Means this one, this element is less than this one is less than this one less than this. Okay, now our second approach is to, we have to count the number of elements in to the right and number of elements to the left. Okay, so first create one Fenwick tree for left. Okay, and we'll maintain the left count also. Here we'll take the left count, one array where we just count the left count, and here it is the left array, left tree, left Fenwick tree. Okay, so here, so it is creating from the one base indexing, so it is the 0th node, and for it, here it will be the first index for first, and second it will be the all to the power 1. Sorry, this will be 2. So now what and all the index we have, 0, 1, 2 and 3. So 0, 1, 2, and what will be the next index in our case as 3. And here it will, as it is a one base index, one base indexing, so it will be the 4, and this will be the 3. How we know where it will be go? So like this one, it is 2 to the power 0, it is 2 to the power 1, and it is 2 to the power 2 directly. But now for 3 is equal to, means 2 to the power 1 plus 2 to the power 0, means we are having this 2 to the power 1, below that there is one more element 3 indexing. Okay, now we have to update this left tree. How we going to update this left tree? So first we'll update the query and then update. Okay, based on the this map array from the starting from the left. So we took the first position 2. Okay, so for second position, first we calculate the query. What will be the query here? So for second position, what will be the left, means what will be the total elements in the left? Currently there is nothing in the left. Okay, what will be there? There is nothing, and we are just, we have to what we have to find beyond this second position, means this is the one array, sorry, this is the array, suppose, and this will be the second position, this will be the second position. Now we have to look into this part, this part for left, and this will be the right part. So we have to look into this side. So here the position is 2, so we are looking for, and it is for one base injection. So first we'll check for 2 minus minus, which will be 1. Okay, started from the 1. Okay, so here query I started from 1, and which you increase to 2, and here, so the indexing is here, and currently each element is having the initialize from the 0 value initially. So previously count is will be 0. for 2. Okay, now we have to update. For updating, we have to update from 2 to till last. So what will be value? We are updating just one element, that one element in the left. Okay, 1 and 1. Okay, like this we are updating till the child node. Okay, now next element is 0. What will be the 0 minus minus is nothing. So we 0 minus minus 0 and 0, so we are getting here nothing, so the total count will be 0. Next element and we have to update also 0 after 0, but nothing will be there, so to update, so we update nothing. Now next index is sorry, we have to update this as 0. So from 0 I have to update I plus 1, position is 0, so we have to update beyond that, so it will be 1, 2 and 3, like this. Sorry, this 0 is going in this as a 1. Okay, let's check how will going into this and how we are going to update. So we have to check the next node. So what will be the next node for this? 0. Currently it is 0, we update it to 1, and if I plus plus doing 1, so it is starting from there, and we have to update till next node. Okay, uh, so its next node is 1, 2 and 4. Okay, and here for this 2, but where we have to update this 2, so we have this 2 is updated in this one, because we have to update this 2 to 3 I plus plus, so it is updating there, and this one zeroth index is updating here 1, 1 and 1. Okay, now next node element will be 1, so we are just fetching from 0 plus 1 is 1, this one, and what will be the count from here till parent is 1, only one element query. Now next we have to update it also from there, so 1 plus here it is value is 1, now we have to shift 1 to next element, it will be 2, so we are just updating plus 1 is 2, and this one is also 2. Now next element is coming 3, so for first we have to update this 3, for 3 we have to update this. What will be the query? 1 plus 2 is 3, so we updated this 3. Now after that we update beyond 3. What will be beyond 3 is 4, so what we updated here, like instead of 2 we updated 3. So our left count array is created here. Similarly we iterate on the mapped array and create a right count, calculate the right count array. Okay, here we are creating right count, and here we are iterating from the right side. So, okay, so the same array we creating here, just 1, 2 and this one is 4, and below 2 is 3. So initially all values are 0 of each. Now we are iterating from 3. So first what we have to do, we have to calculate the number of elements in the right side, in right block, which is greater than x. So how we update this range? So first we calculate the number of elements for whole range, then we calculate the number of elements till this range including a middle, then get the difference, then if we getting the difference we will get this one range. Okay, so first for 3, so first we'll get the range query for whole array. So what will be the range query? Currently all elements are 0, so we get 0 minus, then but we have to get till middle. Okay, till this position 3, so what will be the is 0, again 0, so we are updating this 0 as 0. One second. Okay, so we update the last index to 0. Now we have to update also. After 3, what will be the value? 3 plus 1 is 4. So we have to update one value here. Okay. Now this one element is 1. So we are fetching 1 and do the range query. Same. So for this currently, what will be the whole range query? For this whole elements, what will be range query? 1 minus 1 minus what? For till first index. Till first index it is currently 0. So we are getting 1. So here we are updating this as a 1. Now we have to update till all elements. 1 plus 1 is 2. Okay. Same update. 1 plus 1 which will be 2. So we have to start updating from the second index. So which will be 1 and it will be updated to 2. Okay. Now our next element will be 0. So we have to calculate range query for this. So currently our calculation will be 2. Here we are getting 2 minus till 0 0. What will be the range query till 0 is 0, which will be 2. So here till here our range query will be 2. Now we have to update after this 1. Then it will be 1, then this will be 2 and this will become 3. Okay. Now in the end we have to call it for this second index. So first we'll check the whole index and n will be 3 because this will be 3. Then we have to take the subtract, and for 2 till 2 what will be the sum? 1 plus 2, oh sorry, 2. Okay, 1 plus 2 2, this one 2, then we get the 1 here. So this will be the range query for 1. Now we have to, after that we have to again update from 2, then from 2 plus 1 is 3. For third element we update this value as 1. Now we got the left count also and right count. Now what we have to do, we have to iterate. So just to summarize this, we'll write it down left and right here in both. What will be the left? 0 1, oh sorry, 0 0 1 and 3. And similarly for right, what will be the value? 1 2 1 and 0. Okay, now we will iterating over this and just do, during take the multiplication of each current index and update that. 0 1 0 will 0 plus 0 2 0 plus 1 1 1 plus 3 0 is 0. So what will be the our final answer is 1. Okay, so this is our approach. Now just try to just write, we'll going to write the code for this solution. Okay, let's write it down. So what we have to do, so first we will took the n, which will be the size of num array, nums size. After it, what we have to do, we have to create one vector to map the num array. Okay, of what size? Of size n. Okay, then we'll iterate over the array 2, int I equal to 0, semicolon I is less than, and semicolon I plus plus. Then position of 2 and of I will be, what will be? I. No, what it will be? Sorry, it will be I, but we have to iterate using the nums2 array, nums2 of I. Similarly, we'll create one more array vector of int mapped of size n and iterate over it for loop int plus here we just mapped of I which will be equal to position. Here we are just mapping the num2 array with the num1 array, position of 2 at nums of 1 at I. Okay. Now what we have to do next, we have to calculate the right index and left index. So for that, first we create a class, one Fenwick data structure will create. So okay, so here we took this class Fenwick. Okay, so we took one array of size. For Fenwick tree we have to what size of array, and n size of array. Okay, int n. So for that we'll give one constructor. In public we'll just give constructor of int, where in this constructor we'll get the size, and in this and we'll update the size and assign. We can here use assign, and we can use reassign also. N plus 1 comma and initializing from the 0. Now we are having two methods in this. First we have to update and query. Update, so first we'll going for update. So to update we are having index I, and whatever the value we have to update from that index. So first, as it is one base indexing, so first we'll increment the index and took a while loop like till I is less than equal to n of the size. Okay, then we'll update over the array like bits of I and update the value equal to val. Okay, now we have to update the next index. How we are going to update? We have to find the child node. How we are going to find? I is, we have to plus equal to in the, what we have to do, one second, in comments first we'll write do to's do first we have to do to's complement. So how we are doing to's complement? By taking minus I, then do and with original index, then some, then add that index in original one. Okay, so what we have to do? First we have to do two's complement. This will be the two's complement. Then what we have to do? We have to do the AND operation. Here we doing the AND operation. Then what will be whatever will be the result? That result we have to concatenate, means add in the current index. This is the current index I. Okay, similarly we'll have one more query method, query, where we are just getting the index I, and from that index we are just fetch the range, whatever the range from, and as it is one based indexing, so starting from the I plus plus and doing the while loop, and as less I, here we are just going from bottom to up till parent node. So here the check will be I is greater than 0. And how we'll update? So first we'll take a sum plus equal to bits of I, and Here we just took one element into sum which is initialized from 0, and now we have to modify the I. So similarly we have to do the 2's complement. First we have to do 2's complement, then we have to do the AND operation with original one. Okay, then after that what we have to do, we have to subtract that. Okay, and in the end we'll return that sum. So we have to update this method also int. Okay, so this is our class Fenwick data structure is done. Now just create two object of this Fenwick tree. Fenwick left binary. Actually this Fenwick tree also known as bit index tree. So here I am using this left bit and right bit, just short form for that. And here we'll just initialize with the size also of size n. Now we have to update two arrays. First we'll take your vector of int left count of size n initialize with 0 comma right count of size n initialize with 0. Okay, then what we have to do, we have to iterate over the array. First iterating from the left, int I equal to 0 semicolon is less than n I plus plus. What we have to do, first we have to iterate. First we have to check for the left, for current I, the current index, current I is I which is I equal to 0. So first we will count the left, all left elements in the left count at I, which will be left count at I, which will be, here we are just calling left query, left bit dot query, from which index, ith index. Okay, ith index of mapped array. From mapped array we just fetch the ith index, and for that we call query. But here what we have to do, we have to look into the node. We don't need to include current element, so that's why we just take a subtraction of -1. After updating the count, we have to update array with the current index. Left update with I. Okay, here we update that. Similarly, in the similar fashion, we'll iterate from the right. Int I equal to n minus 1 semicolon I greater than equal to 0 I minus minus. Okay, similarly calculate the right query, count of I which is equal to, so what we have to do here, we have to first call the query for whole array, then subtract the query till current element. So just write and just go right bit right query of size n minus 1 minus में bit till map at I. ठीक, and after that what we do, we are doing here right bit dot query. Now we have to update right bit dot update map of I. Okay, now we are getting both left count and right count. So taking a long result which is equal to 0 semicolon for loop 0 is less than n plus बराबर है typecasting the result into the long and left into में right count at I. Similarly, we have to take left count at I, and in the end what will we do? Return the result, whatever the result it is. Okay, just run it and check it is if there is any error or not. So here it is showing some error. So in this left bit dot update mapped of I is showing one error. Why it is showing one error? Because during update we did not send the value, whatever the value we have to update. Similarly, in the right method also we have to send value. So we are updating one value for each element to represent there is a one element in the left or one element in the right. Okay, now just try. So here also it is showing some error, left count of I and right count of I. Okay, this one is the error. I am doing too much error. Now the code is accepted. Let's try to submit it. um, I already did this. Okay, it is showing some error. Hey, 1 second, let's look into the code. What's the error? Left count and right count of I. Runtime signed integer overflow and not represented a type. Okay, 1 second. Instead of doing this, just 1L times converting the things into the long and not taking it into the long, just convert it. Okay, now it's submitted. Now just looking to this code, what we are doing, we are took two separate Fenwick tree for left and right. Okay, so there is one more solution that we can achieve this problem, solve this problem using only one set. Because what's our approach? We have to calculate number of elements to the left, and based on that information we'll count the number of element to the right using the same. So how we can iterate that? Just as of now, just comment this whole code. Okay, and just try to check how we can achieve this. So first we'll take a long the result, which should be initialized with 0. Now what we have to do, we are going from left to right. Int I equal to 0, semicolon is less than I plus plus. The same approach, whatever we did, the same we have to do here. What we are doing, first we'll get the current position, int position, which will be the map that I. Okay, now what we have to do, we have to count the left from left side number of elements which is smaller than this position. Okay, then int left, which is equal to bit at bit dot query, and for which query, for position. Okay, then after it what we have to do, we'll update the left. Okay, so what we are doing here, we just calculate it for the left, then update the left also for all. Okay, got it. What we are doing here, now we are having the information of left, and we updated the left also, left element, okay, in the Fenwick tree. Now we have to calculate right. Then how will calculate right? So as of now, how many numbers means, as of now total number of position in the right. What will be the total number of position in the right? First tell me the total number of this. Total number of elements is n. Okay, and now the current position will be pos. So there are total number of position including the position is n minus position, and if we took the subtract 1, then we exclude the current element. Okay, then what we have to calculate, this is the total number of position to the right side. Okay, now we have to calculate till how many elements we checked as of now. Okay, so as of now we checked I elements. How many elements we checked? I elements. And from that I elements, number of left element will be, we have the information of left, so we took the difference of that. So I minus left means there is left element, left is the number of elements in the left, and this I is the number of elements we checked. That means the rest of the elements is in the right, so we took the difference in the total number of position in the right and the difference. Okay, this will be the right. So here we'll update the result. Result is equal to left into right. And similarly, the same problem what we faced to convert long, here we multiply that long. Just check once, check the solution. So this is also working. Let's check by submitting. Okay, it's also working. Okay, so as of now we can conclude the call here. Thank you all.